Let's try converting some equations between polar and Cartesian equations and coordinates. So, for example, I have no idea what that curve represents there. There's a couple ways I could look at it. The first way, I'm just ignoring the problem for a second, but if I want to know what a picture of this is, I could just plug in some theta values and get out some r values, just like I always do. Now, here I'm told that my theta value should be between pi over 4 and 5 pi over 4, so I'll pick things like pi over 3, pi over 2, 3 pi over 4, pi, and then I can slip in let's see, what would that be? A 7 pi over 6 would still be in the domain there. And if I plug those in, I get sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. Here at pi over 2, I get 1 over sine of pi over 2. That would be 1 minus cosine would be 0. So I know what that one is exactly. That's a 1. This one's a little bit harder. That's 2 over root 3 minus 1, something like that. 5 pi over 4, I would get root 2 over 2 minus a negative root 2 over 2. So I get 1 over root 2 there. For pi, I get 0 for sine and negative 1 for cosine, getting us a positive 1 again. And then for 7 pi over 6, I would get negatives for both of those, negative 1/2 for sine, and then I would get a, what would that be? Negative root 3 over 2 for cosine, and so that would get me, bring the 2 up to the top, root 3 minus 1. And I'm not entirely certain of what that number is either, but I can go ahead and plug everything in, and then I get these points. Let's do the easy ones. I get pi over 2 at angle pi over 2, which is going up here. I go up 1. At pi, I go to the left 1. And then let's see, 3 pi over 4, which is halfway in between, I go out 1 over root 2. That's the same thing as root 2 over 2, and that's actually smack in between them right here. And if we're very careful and we try and plot these other 2 points going out pi over 3, that turns out to be this far, and 7 pi over 6 turns out to be right here. And so while it might be tough to see, this is actually a straight line. All right, but in order to know that it was a straight line, I had to plot some pretty difficult lengths here. So this is not really the best method for graphing this particular polar curve. This is why the question suggests that you convert it to a Cartesian equation. Okay, so that's all well and good. Let's start from scratch and do the actual problem, which says convert it to a Cartesian equation. And in order to do this, we'll need to remember things like x equals r cosine of theta, y equals r sine of theta, x squared plus y squared is equal to r squared, and finally we have that tangent of theta is equal to y divided by x. Okay, and so what I can do here is I've got the sine of theta and this cosine of theta, so maybe I'll rewrite this a little bit. I can multiply the top and bottom by r, so I get r over r sine of theta minus r cosine of theta, assuming that r is not equal to 0. And then I can just cancel that r on both sides. 1 over 1 divided by r sine is going to become y. R cosine is going to become x. And so then I'll just multiply this back over here to the left. Y minus x equals 1, or y equals 1 plus x. And that, of course, is the equation of a straight line. And you can see that that would be the same straight line that I drew a picture of just a moment ago by fumbling around trying to plot those polar coordinates. We get that exact same picture here. Okay, so that's good news. Let's take a look at going the other direction. Maybe we have a Cartesian equation but it would be much better served to be expressed in terms of polar coordinates. And usually that involves things like circles or anything that's circular in nature. So here we have our example. So if I want to convert the Cartesian equation here into a polar equation, let's see what I can do. I'm going to go ahead and maybe multiply out that square here. That would become x squared minus 4x plus 4 plus y squared is equal to 4. And the reason why I do that is because I saw that I would have an x squared plus y squared term. And so that x squared plus y squared term I'll group together. And then also I can cancel these 4's here and here. So I get x squared plus y squared minus 4x equals a 0. And here's where I can use the fact that x squared plus y squared is r squared, and x is r cosine. Okay, assuming r is not equal to 0, we'll cancel both of those r's there, and I get r minus 4 cosine of theta is equal to 0, and r is equal to 4 cosine of theta. And there is my polar coordinate equation for, what is this? This is actually a circle, but it's a circle that's not centered at the origin. This is the circle of radius square root of 4 is 2, at the centered at 2 comma 0. So here's a picture of this particular circle, and here is a very simple polar equation describing that circle. It's a little bit simpler looking, I think, than this original circle equation, and it's also a nice function. R is a function of theta. Here, there's no vertical line test, so y is not a function of x, nor is x a function of y.